Hello guys, welcome to math class today. In today's episode, we are going to be discussing binomial expansion. Binomial expansion using Pascal's triangle. Binomial expansion using Pascal triangle. I welcome you to binomial series. Okay, at the end of today's class, you should be able to use Pascal triangle to expand a binomial expression of the form a plus b all raised to power n, where n is a positive integer. At the end of today's class, you should be able to use Pascal triangle to expand a binomial expression with a positive power. Before we kickstart today's class, or at the end of today's class, you should be able to solve the following questions. Here will be the practice questions for you. Question 1 to 16. So, before we start today's class, let's check out our starter activities. You can pause the video. When you are ready to see the answer, then you play the video. We have the starter question here. Use Pascal's triangle, expand 1 plus x all raised to power 3. Use your answer to part A to express the I and II, and use your answers to part B to simplify what you have in C. So when you are ready to see the answer, play the video. Alright, let's check the answer to this question. Here is the answer to the question. Yes, congratulations to those people that got the starter activity correctly. But if you find it difficult to solve the starter question, come, let's discuss Pascal triangle. We are familiar with number pattern. When we talk about number pattern, we talk about a particular sequence that has a specific rule that governs them. If I have something like, okay, let me just pick my marker. I have something like 1, 2, 3, 4. If I ask you to find the next 3 terms, okay, thank you, class. You have 5, 6, and 7. This type of sequence increases by 1. I can have a squared sequence. 1, and I have 4, I have 9, I have 16. Yes, the next one will be what? 25. Thank you. 25, 36, and 49, so on, so on, so on. That's the squared number. Square root of 1 is 1, square root of 2, and so on. We also have something we call Fibonacci series or Fibonacci sequence. Example of Fibonacci pattern is like when you have 1, you have 1 again, you have 2, you have 3, you have 5, you have 8, you have 13. The rules that govern this is the addition of the subsequent numbers. 1 plus 1 gives 2, 1 plus 2 gives 3, 2 plus 3 gives 5. This type of sequence is called Fibonacci. Okay? Alright, we can also expand if you have 2x plus 2 and we have, let's say, 1 plus x. We know how to do this expansion such that you have 2x open bracket 1 plus x and plus 2 open bracket 1 plus x. We can do that straight up. Just expand the bracket where we have 2x plus 2x squared plus 2 plus 2x. Then you can collect like terms, which will finally give us 2x squared if I rearrange plus 4x plus 2. That is a little expansion. Okay, moving on. Now, if I ask you to expand a plus b all raised to power 2, in this episode, we are going to be dealing with binomial. the word binomial means two. The word binomial means two terms. When we say binomial expression, we are saying an expression with two terms. I know you are familiar with this. Two terms, and the power is positive. If your n is positive, you can apply Pascal triangle. In our subsequent episodes, we are going to see if the power is negative or less than 0, or when the power is not positive. Okay? You can expand a plus b all raised to power 2. Okay, what will the answer be? From your previous knowledge, you have here square the first term, which will be a square, 2 times a times b, that's 2ab plus b squared. Did you remember this? If you don't remember that, you can just do as ab times ab. Then you apply the method I use here, okay, to expand the bracket. Okay, if you look at this, let's write out the coefficients. Coefficient of a squared and ab and this here. Coefficient there will be 1, 2, 1, 1, 2, 1. Okay, in Pascal triangle, we have what they call Fibonacci's. You understand what I call coefficient? That is what is in front of a squared, what is in front of 2, what is in front of ab, and what is in front of b squared. The coefficient of a square is 1, this is 2, and b square is 1. Okay, I can use Fibonacci series to form Pascal triangle. I've told you Fibonacci series or sequence is you add the first two numbers. If I move this one here, I add 1 plus 2, it gives me 3. I write 2 plus 1, it gives me 3, and I move the 1 down again. I can go on, put 1 down, 1 plus 3, it gives me 4. 4 plus 3 plus 3, it gives me 6. 3 plus 1, it gives me 4, and I move 1 down again. I can also go down 1 minus 1 plus 4, it gives me 5. 4 plus 6 gives me 10. 4 plus 6 give me 10 again. 4 plus 1 give me 5, and I move down 1. Let me move 1 again and go down a little. 1 plus 5 give me 6. 5 plus 10 it give me 15. 10 plus 10 it give me 20. 10 plus 5 it give me 15. 5 plus 1 it give me 6. Then I move 1. This thing forms a triangle, and these are the coefficients of the binomial expansion at a particular degree. We use Fibonacci series or Fibonacci sequence to arrange or to form this table, to form this triangle. You can see from here, this is the coefficient when a plus b raised to power 2. This one is for power 3. This one is for power 4. A plus b raised to power 4. This one is for power 5. A plus b raised to power 5. This one is for power 6. A plus b raised to power 6. You can keep on producing the pyramid or the triangle like that, like that, like that, like that, and it will move on. So how will I apply? Mind you, these are the coefficients. Yes, the Pascal triangle shows you the coefficient of that binomial expansion based on the degree. Now, let's apply this. Let's apply this. Let's apply this. I will just pick one or two to tell you how to apply this. Now, there's something you need to know which is very important. If I'm to expand a plus b raised to power 3, from the first one I did, you discover that the power of a is decreasing as power of b is increasing. In this place, b is 0, and when a is 1, b is 1. In this one, a is 0. You can see that the power of a is decreasing. You pick the first letter a, and the power of your n will be that power of a, and b will be 0. So let me apply this Pascal triangle to this. The coefficient of power 3 will be what, class? 1, 3, 3, 1, right? So I'll pick the first one, 1a raised to power 3, b raised to power 0. As a is decreasing, b is increasing, plus I pick the second one, 3a raised to power 2, b raised to power 1. A has started decreasing. I pick the next coefficient, 3, a raised to power 1, b raised to power 2. Then I'll pick the last one, which is 1, a raised to power 0, b raised to power 3. So I can write coefficient of 1 a raised to power 3, b raised to power 0 is the same thing as a raised to power 3, as we know that b raised to power 0 is 1. This one will be 1, and a raised to power 0 too is 1. So plus 3a squared b plus 3ab squared plus b cubed. So the pattern here is, as the power of a is decreasing, b is increasing. That is how to apply Fibonacci Pascal triangle to expand positive. Okay, somebody is telling me, if assuming they give us x plus y, a and b can be any number raised to power, let's say 5, raised to power 5. How am I going to expand this? Let me quickly do it. The first thing you do, you write out the coefficient of the fifth expansion, which is 1, 5, 10, 10, 5, and 1. And mind you, as the power of x is decreasing, the power of y is increasing. So I will say x raised to power 5 plus 5 x raised to power 4y plus 10x raised to power 3y squared plus 10x raised to power 2y cubed plus, let me write this one very well, y cubed plus 5x y raised to power 4 and plus y raised to power 5. So that will be the expansion. Anytime you are given any question, you just need to write it out, the coefficient of that order, and you moved on. Okay, let's take practice question. I just use that to illustrate. Let's do more examples. Let's look at this one. I've done question 3, I've done question 1C. Let me quickly explain question 1B, then I will do question 2, or I should go straight up to question 2. I want to write out the expansion for x squared minus 1 all raised to power 4. What is the value of n here? My n is 4. I will write out the coefficient for the expansion of degree 4, which will be 1, 4, 6, 4, and 1. Yes. So I know that my a is x squared and my b is minus 1. Yes, if I'm writing it in form of a plus b all raised to power n, my a is x squared, while my b, please pick the minus sign with it if it is not positive, minus 1. So let's apply it and put it at the back of your mind, as a is decreasing, b is increasing. So I have 1, my a squared, which is my a, which is x squared, is of power 4, plus I have the second coefficient 4, my a, which is x squared, then the power is reducing now, raised to power 3, and my b raised to power 1. The sum of their power should still be your n. Okay, plus I'm going on 6, I pick my a, which is x squared, and the power now will be 2, and b will be 2, thank you, which is minus 1 squared. I'm going on 4, I pick my a, which is x squared, which is power 1, and my b minus 1 raised to power 3. Please, this is 2, Then I'm going for the last round. My A will be 0 there, so I don't need A. I only have my B raised to power of 4. Okay, raised to power 4. So I can now simplify this. 4 times this will give me x raised to power 8 plus, will it be plus? This minus will come out, that is minus 4 x raised to power 6. The minus here will be plus, and I have 6 plus 6 x raised to power 4 plus, is it plus or minus? It should be minus. Thank you. Because when you take minus 1 cubed is minus 1, I have minus 4 x squared, and that should be plus 1, and that is the expansion that we are looking for. Very simple and straightforward. All right, I have that, and the question asks me to find the coefficient of 1 minus 2x squared times x squared minus 1 all raised to power 4. I should find the coefficient of x raised to power 6 for this. I know this part to be this in red, so I will just multiply with these parts. So for it to be the answer I will do, I'm multiplying this. I will multiply 1 minus 2x squared with everything here. Yes, to do number B. So what I'm going to do is, I know if I use 1 to multiply throughout, for me to get degree 6, x raised to power 6, it will be this term, which will be 1 multiplied by minus 4x squared, 4x raised to power 6. That will be the only one that we have in that term. And for minus 2x, I can have minus 2x squared to multiply this only term will be the one that will give me power 6. If you like, you can expand everything, but because of my time, I will just pick those ones that will make it to be x raised to power 6. If I use this one to multiply all this, is only minus 4 x raised to power 6, that will be power 6 for the first part, and for minus 2x squared is only that one that adds 6x raised to power 4 that will make it to be power 6. So I can expand it to be minus 4x6, and this one should be minus 12x6. Okay, so this one I can add the coefficient outside, which will be minus 16x raised to power 6. So the coefficient for power of 6 is 16. Coefficient will be negative 16, and that is my answer. Please practice question. Yes, you can see it. You do question 4, you do question 6, and you do question 12, and you do question 15. See you in next class. Bye.